Hi there, welcome to Mind Builders Hub. Don't forget to subscribe in our channel. Today, we're going to talk about the free body diagram. Physics is the branch of science that deals with the study of matter, energy, and their interaction. It seeks to understand the fundamental laws and principles that govern the behavior of objects in the universe. One essential concept in physics, particularly in mechanics, is the free body diagram. And free body diagrams are graphical representation that helps us to analyze the forces acting on the object and understand how those forces influence the object's motion or equilibrium. So to start, let's move on to the objective. We need to apply free body diagrams to various objects that have forces being applied to them. So in a free body diagram, or the study of free body diagram, it is fundamental that we need to understand the mechanics of everyday objects, the celestial bodies, machines, and complex systems. It forms the foundation of Newton's laws of motion, which are essential for comprehending various physical phenomena. Whether you're a student, an engineer, a scientist, or simply curious about the world around you, learning how to construct and interpret free body diagrams are greatly enhance your understanding of the physical world. So in here, forces can be seen based on how they act on the object. That is what the free body diagram wants to show us. Look at the picture and you will see that forces acting on an object can be shown by representing them as arrows. An FBD or free body diagram is a diagram showing all the known and unknown forces acting on the object, indicating their magnitudes and directions. So what are the key points that we need to understand? Number one is called isolation. In isolation, you have to focus on a single object or body. After that, you have to remove all other surrounding objects or bodies that are not directly interacting with the object in question. Like I have here an object on top of another object, and what I want to see or for you to see is that I want you to see that there is a normal force acting on it and the weight of the object. Number two, it is called the forces. You need to identify all the forces acting on the object, and forces can be of different types, such as it might be gravitational force, normal force, tensional force, frictional force, and even applied force, like in the diagram here, or free body diagram, showing all the forces, like normal force being pulled going to this direction, and then a frictional force plus the gravitational force. Number three, the directions. It represents each force as an arrow, indicating the direction in which the force acts. The length of the arrow may represent the relative magnitude of the force. Number four, labeling. Label each force to indicate its nature, like the force of gravity for gravitational force here, then applied force or F, applied for applied force. You have to label it. You also need to consider the following. Number one, pulleys are assumed frictionless. Number two, pulleys are assumed weightless. And number three, ropes, cables, cords, and wires are assumed weightless. To apply, let us see this example. Consider a book on top of the table. This is a book. And then, how do we see the forces acting on the book? Look at the arrows. Let's analyze. To see the forces acting on the book, we first separate the book from the table and from its environment. Our focus is the book. Next, since the object has mass and Earth's gravity acts on it, then the book has weight. Next, weight is always directed downward, so the arrow is drawn with its arrowhead pointing downward. The book is also in contact with another surface, the surface of the table. The force present whenever surfaces are in contact is called the normal force. So that's it. I hope you learned something about the free body diagram. We need to study them for us to be able to predict the motion of the object, understand stability, problem-solving skills, and even scientific inquiry. So in conclusion, the study of free body diagrams in science is crucial for comprehending the fundamental principles governing the motion of objects. It offers valuable insights into the behavior of various systems and provides a solid foundation for further studies in physics, engineering, and other scientific disciplines. By learning how to construct and interpret free body diagram, we gain a deeper understanding of the world around us and the intricate interactions between objects and forces. So that's it for today's video. Thank you very much for listening and watching. Bye bye.